There's one comment that I really like, which is saying multi-agents are like microservices. On architecture perspective, that is true. Single agent is monolithic, yes. Rather than having a single huge piece of work, whether it's an agent or software, it's harder to manage, it's harder to maintain. We will break it down into smaller pieces. If you add more logic to that agent, it's either going to make the prompt very complex or the number of tools very large. And unless your LLM has like the capacity to scale with this, your quality will drop. Do parallel agents running at the same time, we'll get faster responses, but we are paying something to get that. Also, if you can actually run multiple agents, you can basically reduce hallucinations, basically by getting consensus from different agents. All right, cool. So let's get started with multi-agent. Before that, I want to go quickly for an intro about myself. I work as an ML engineer at Google. I spend most of my time working on GenAI applied problems. This means that I do not work on training the foundation model. Instead, I work on using the existing foundation models and using them to solve business or engineering problems. I spend most of my time on the applied side, and I try to talk about applied aspects rather than the theoretical parts. Before that, I spent some time in academia doing regular academia things, which are teaching and research on different ML topics. So that's a brief intro about myself. As I mentioned earlier, I will talk about multi-agent systems. And basically, so far you have learned about the foundations, like things like retrieval augmented generation and what it does it mean and what are the main components. And then you learn a little bit about how to build a single agent. And you saw some coding demos probably to build that. And you learned also about MCP.
You can spend months learning agentic AI or cut that time into half with a structured program by Interview Kickstart, where you actually build and ship 2 AI agents into production with a mentor from Faang guiding you through every step. It's called Agentic AI Career Boost Program. And if you think it's just another generic course, spoiler alert, it's not. It's customizable depending on your domain. Engineers, you have a Python-based AI engineering path. If you're a PM or a manager, you take no-code, low-code use case path. And both paths could be paired with Faang interview prep for AI-driven roles. But the best way to learn more about this program is through the free webinar. Here you can get all the details about the program, ask your questions, and see if it's the right fit for you. And if it is, you'll be joining a company of 25,000 professionals who have already leveled up through Interview Kickstart. Many now at Faang, Anthropic, OpenAI, already crossing 300K plus. And here is what some of them say. I'll put the link to the free webinar in the description as well as pin it in the comments so you don't miss it. See you all there.
Now we will focus on like the scenario where we have multiple agents that basically mixes different capabilities and helps you achieve more sophisticated goals. So we have like a list of subtopics. We will start first by talking about why in the first place we need to have multi-agents. And then once we have like enough reasons to have multiple agents, we'll talk about different architectures for how these agents can communicate with each other. We will dig deeper a little bit into the communication mode. And then once we have multiple moving parts, this can pose different security and safety risks. So we'll talk a little bit about that. And then briefly, we will talk about operations. So basically things like evaluation, scaling, different frameworks that we can use. And then we will see a coding demo, and then we will wrap up the discussion about some anti-pattern designs that we should avoid. So the last few topics, we'll talk about these last 4 ones very briefly. We're not going to spend too much time with them. I'm going to spend most of the time with these topics and the coding demo. So before we actually get started with multi-agents, we need to know why we even think about multi-agents. So if people can share with me on the chat some thoughts on why in the first place we will need multi-agent system instead of a single agent. So rather than having a single agent with a single set of tools, why would we need to have multiple of these? Any thoughts on the chat? If you can share your thoughts, that would be great. Specialized agents for different tasks. Yes. Scalability. Scalability is an interesting thing. We'll talk a little bit about scalability. Each agent will be simpler. Yes. Each agent will do a simpler or more specific thing. More complex problems, yes, this is a great point. There's one comment that I really like, which is saying multi-agents are like microservices. On architecture perspective, that is true. And I will keep this comment because it will make explaining the architecture for me way easier. So yeah, thanks for that comment. Complex tasks, balance checks, we will talk about that as well. Single agent is monolithic, yes. So this is very similar to the idea of having architecture like microservices, right? Rather than having a single huge piece of work, whether it's an agent or software, it's harder to manage, it's harder to maintain. We will break it down into smaller pieces. A single agent can handle one task at a time, quick response. Quick responses, depending on how we are implementing them, increase the number of applications, complex workflows, each agent will perform a task. Okay, awesome. So I think almost all people agree that task complexity is one of the reasons why we need to have multi-agents. So basically, the whole idea is a single agent can perform relatively simpler tasks. If you add more logic to that agent, it's either going to make the prompt very complex or the number of tools very large. And unless your LLM has like the capacity to scale this, you will run out of like quality. Your quality will drop. So basically, rather than asking your agent to do everything, you're gonna break down the problem into smaller sub problems, small for multiple agents to work together.
If you're still using old Faang prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern Faang interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan, the exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description.
If you actually run your agents, these different agents in parallel, you can actually achieve more within the same time budget. If we actually run agents in parallel, it seems that we're going to get the same response relatively quicker, but at what expense? If we run agents in parallel, we will get faster responses, but what are we paying for this instead? If we do parallel agent running at the same time, we'll get faster responses, but we are paying something to get that, a default thing. More resources, right? Or more TPUs or more GPUs or more money. So we're paying money for that. So we should be making all of these decisions consciously. We should be aware of the pros and cons. And speaking of like the skills that you need to have, what I have seen is basically people working on ML related jobs. There are either people on the quality side, people who train the foundation models and they know how to train them and how to deploy them, and people who actually use them in the applications. And these are one of the decisions that people who use these models in applications have to make. Like, do I want to trade money for latency or latency for money? This is where it's more important even in multi-agent system. We'll talk about different architectures later. So basically, one of the things that you should think about is task complexity, whether you will run these in parallel or not, and what are the implications on the latency and the cost. Also, if you can actually run multiple agents, you can basically reduce hallucinations, similar to what some folks have said, basically by getting consensus from different agents. If you run multiple agents and they give you the same response, then it's very less likely that this is hallucination. If there's a disagreement between them, then this is basically a signal that there should be a signal that there's a higher chance to see hallucinated results. Not all problems lend themselves into a multi-agent. Some problems actually you have a single agent should be enough. So basically, if your task is simple or if your task is sequential in nature or it doesn't require extra processing, you should use single agent. So the answer is not always multi-agents, depending on the problem itself, depending on the cost analysis or return on investment versus complexity. You should make that decision, and it's on the ML engineer who is building the application to make that assessment. As we mentioned earlier, the cost, the number of how much TPUs or how much GPUs do you use is one deciding factor. As we will see, you actually require more LLM calls for a multi-agent system, which is kind of intuitive. So you should keep this in mind. Also, whether you would expect performance gain or not. Basically, if your problem is simple, you will not see a performance gain by moving into a multi-agent system. So basically, these are one of the decisions on the person who is designing the system should take into account. So some of the problems, for example, to give you some examples on like cases where multi-agent system can make things even worse, is if you are over-engineering your simple problem. You have a trivial problem, you over-engineered it and decided to use a multi-agent system. then actually this is an anti-pattern that you should try to avoid. Sometimes your agents will either keep exchanging unnecessary messages, which is basically burning money for you, or they can keep running in like infinite number of retries, or they can even complicate things. I think there was some recent research by Apple, I think. They were just showing that if you show some of the models simple math problems, they tend to overcomplicate things. So again, if you have multi-agent system that is overfitting or over-engineering a problem, you are more likely to run into this plan drift. So I'm just including this slide to tell you that multi-agent system is cool. It solves complex problems, but you should not be using it for every single application that you have. So now we have an idea about when to use multi-agent system, which is basically for complex problems. If you understand the return on investment versus cost or versus complexity. So let's say that we decided to use multi-agent system. We did this homework and we decided to use multi-agent system. And the question is, how can we architect our multi-agent system? How do we structure our multi-agent system, right? So we know that a single agent or a single agent system will mostly consist of an LLM that has access to multiple tools, right? One or more tools. And plus that, you will have probably a memory because your LLM is stateless. So you will add a memory to your... But what about multi-agent systems? What are the different ways that we can architect these agents so that they can communicate with each other? What are people's thoughts? Let's say that we have 3 agents or 10 agents, whatever the number of agents. How can we have, or what architectures can we use to organize the communication between these agents? Let's see what people think. Shared memory, okay. Parent agent plus child agent, yes. Like some form of hierarchical architecture, yes. MCP protocol is actually not for agents. MCP protocol is more for agents that communicate with tools. So MCP actually will fit somewhere here, more or less. There are different protocols for agents, similar to MCP. They are called agent to agent. They are developed by Google's ADK. So yes, A2A is developed by Google ADK. But what are the different architectures regardless of the implementation? A coordinator agent or supervisor agent, yes. A message passing, okay. Orchestrator. Okay, so basically people mentioned different architectures. One of them is the idea of having supervisor agent, right? This is basically the agent that, let's say that our problem has 3 agents, right? Research agent, writer agent, and spelling checker agent, whatever number of agents. Every agent will perform their own task, and they will basically transfer the control back to the supervisor agent that will look at the next step. So basically, this supervisor agent will be your entry point, right? This will be the entry point. And then based on the question, it will decide that I need first to call the research agent. And then the research agent will use a bunch of tools, does its job, and then it transfers back the control to the supervisor agent, and will call another agent, and so on and so forth, right? So basically, this supervisor agent, how would it make the decision on which agent to call? What do you folks think? How would this supervisor agent make that call? It will basically use another LLM. It will provide to it the question, the context, and you will start to see actually that the supervisor agent, to make the decision here, for example, after it called the research agent, if it needs to decide which agent to call next, it will need to call an LLM, right? It's an agent that has access to an LLM, and the prompt it will send to the LLM most probably needs to contain the history. What agents I called before, and what did they say, and what then give me the next step. What is the problem with this? If we actually keep adding the history to all the calls that the supervisor agent makes, there's an obvious problem that you can think of it. Let's see. Bias is one of the problems. It's resource intensive. Context length, yes. Yes, thank you. So basically, yes, you will run out of context and the calls will be more expensive. So basically, it's with every single time you want to call an agent for the user question, you will have to recite the whole history, rerun the whole history through the LLM so that it remembers what happened in the past. This actually increases the cost and the latency also, because you're just increasing the prompt that you send to the LLM. So this is obviously one of the limitations of the supervisor agent. Also, if you decided to add a 4th agent here, then this will make the problem even worse. So what is the other alternative to the supervisor agent? How can we make this a little bit better? Can we actually make the hierarchy a little bit different? rather than having a supervisor agent that is responsible for everything. We can have like some form of hierarchy. So an example of this could be if you have an agent that does so many things, it actually writes code and it makes design, and this design has UI design and UX design. Rather than having the supervisor agent being aware of all the agents, we're going to abstract all the agents that are related to the programming. We're going to abstract them with a programming team supervisor or another sub agent. And this sub agent will take care of the communication between these agents. And then basically it reduces the things that it needs to worry about. And then the supervisor agent will use these layers of abstraction. So it's basically reducing the responsibility for each of these agents by creating a layer of abstraction. Of course, this increases the number of agents because rather than having the actual agents only, we're adding some form of middle management between the supervisor agent and the actual agents. But on the flip side, it reduces the number of agents that each one of these supervisors have to worry about. So it's just like, as someone mentioned earlier, you can think of this as designing microservices, and you have like large number of design options, and there's no one single design pattern or a specific design that solves all the problems. Does that make sense to people? Any questions so far? Okay, awesome. Let's see. Then this is still problematic because we add unnecessary agents in between, right? Like we have we started with one supervisor agent, we were not happy with it, and then we said like let's add a bunch of other supervisor agents. What are the other alternatives that completely get rid of supervisor agents? What are people's thoughts? What about we actually get rid of all these supervisors and then let every agent talk to any other agent? So each agent will be aware of all the other agents. They can just send a message to that agent. Or it doesn't have to be like this. It could be more of PubSub or like publisher and subscriber, where basically this is where like things get like really interested from systems perspective. I personally prefer this pattern. I work on many projects that uses this pattern, where basically me as one agent, I publish a message. I say, I am done with this piece of work. Anyone who is interested in this type of output, for example, research output, can subscribe to my broadcasting channel or something like that. And then other agents can subscribe to the message, and then basically they can process it or drop it completely. And then they do the same. So it's basically publisher subscriber design better. And again, this is really from this point, it's very like it's in the intersection between machine learning and design. And people who have this both skills are actually doing very well in this position because they understand system design better and they also understand the implication of quality. So in this scenario, we're not adding any intermediate agents that are just there to coordinate the connection between the different agents. Every and each agent can communicate with all other agents or sub number of agents. So you can basically have a full network, or you can have like some form of sub network between the different agents. Both options are available, where basically all agents could talk to each other, or like some custom network agent. This is great. It doesn't add unnecessary supervisor agents, but there are problems with this. What are the problems with this? There are different problems. Debugging any debugging any publisher subscriber pattern or design will be extremely difficult because it's not sequential, right? Like you don't know who received the message, who decided to subscribe to it. In some cases, agents have to be aware of all other agents, which also can be quite messy. And also the infrastructure that will support this design pattern has to be really scalable. It has to give you lots of visibility into what's going on. So this is, in my opinion, is a great design that hits multiple, or basically provides you with multiple compromise between different two extremes or two ends of the spectrum, but it requires having very solid infrastructure to support this publisher subscriber. It requires a good monitoring and logging system to tell you exactly what happened, and debugging this will not be as easy as any sequential like something like this where you exactly know where the call went because it's a single point that makes a decision, or even that one, it's a hierarchical one, but you can easily trace it. So that's basically the trade-off that you'll have to think about. Okay, let's see if there's questions on the Q&A. I think it is based state machine is okay. So it's not fully a state machine. There are some variants of this like LangChain, which it's very close to state machine. We will talk about this. But yeah, that's very close to state machine. One of the implementation is LangGraph, sorry, not LangChain, LangGraph, which is very close to state machine. One question that says, what if you use a protocol like precision time protocol to provide time-based context for network agent calls? You can use different protocols for agents to talk to each other. We're going to talk actually about some of the specs for the protocols. One of the things is that the whole GenAI field is relatively young, right? Hasn't been there for 3 years. Protocols are evolving. Everyone is proposing a different protocol. I think give it a few years and then people will settle down on the specific protocols to use. We haven't talked actually about how these agents will talk to each other, what goes in here, and we haven't talked, but regardless of the architecture, basically, what are the protocols or how do these agents talk to each other? Who takes the decision for which architecture? It is the ML engineers that work on building the application. So I have seen few different patterns where in relatively smaller teams or smaller organizations or smaller companies that each product team makes their own decisions, right? Like we want to build a multi-agent application. Let's reuse LangGraph or True AI or something like that. In larger organizations or larger companies, they build their own infrastructure in-house, and you have like some form of infrastructure team, and then product teams connect to these existing capabilities. It's something similar to saying, who builds the database management system, right? Some companies like Meta and Microsoft and Amazon and Google, they build their own database management systems. Smaller companies use or reuse something that exists. So that's the same for GenAI. This is the pattern that I've started to see, where infrastructure for building agent applications is becoming extremely important, because if you don't have solid infrastructure, you can't ship good applications. Okay, since people actually started talking about the communication between the different agents, one of the most common patterns that I see for these communication between these different agents, regardless of the architecture, is through what people call handoff, where basically it's a very common pattern for agents to interact with each other, where basically one agent hands off the control to the other one. This other agent can be the supervisor in the hierarchical architecture or the supervisor architecture, or it could be another agent in the network architecture, right? It's a general or very flexible protocol. You need to specify the destination and the payload, the information that you send to the other agent. So to give you an example, it could be something like, this is a LangGraph implementation. We basically, on a specific agent, you specify what is the next agent, the next node that you will go to it. If you specify a supervisor agent, then you are actually in a supervisor architecture. If you specify another completely different agent, then you're basically in more of like a network agent where all people can talk to each other. And then here, you basically share the context that you want to hand off to the other agent. So basically in this application, before the research agent hands off the control to the spell checker agent, it adds some state updates on or context that should be passed to the other agent. Okay. Any questions? Let's see. Does handoff is a producer consume better? The handoff can happen in producer consumer or in supervisor. It just like, it doesn't really matter. It's more about how these different agents will talk to each other, regardless of talking to a supervisor or another neighbor agent. In handoff, does the agent need to rely on what previous agent passed or need to know with original input? Really good question. I have dedicated slides for this, but the short answer is it's almost always the case where you need to know the original question and at least what the previous agent has produced. These are at least the two pieces of information that you need to know: the original question and what is the latest agent's output, so that at least the agent knows what the problem is trying to solve. How is the performance measured in multi-agent architecture? We'll talk about this towards the end, but mostly we're interested in the quality of the output, the cost, how many tokens have been produced or consumed, and the latency, right? These are the main three things. Any use case on when do we use network agent? I used network agent in almost all the multi-agent applications that I used. year or year and a half ago, actually a little over a year and a half ago, people were using supervisor agent mostly because the quality of the LLMs at that point in time was not great. So you couldn't have like agents that are dedicated to specific domains. We couldn't have like LLMs that can handle user questions and also make the routing. So we needed to have a supervised agent that is not confused by fulfilling user requests and at the same time making routing decisions. But now LLMs are much more better, and then we can basically afford to have a network agent. For infrastructure, you think system design is important. 100%. You can't make a good system. You can't make infrastructure without system design. Is network agent same as LangGraph? LangGraph implements network agent. Will we talk about observability like logging agent? We are going to talk about observability very briefly. Okay, awesome. So let's continue for the content, and we will take like other breaks and we'll talk about different questions. Okay, so we're talking about handoff very abstractly. Let's actually dig a little bit deeper into what are the information that are passed between different agents? Because actually there was one of the questions about like, do we pass everything? Do we pass only the question? Do we pass only the output? And this is basically the third topic about the communication and the state management between different agents. So what do you folks think should be the information that is passed between different agents, regardless of supervisor architecture or network architecture, or regardless of the architecture? Two agents, one of the agents want to hand off that they control to the other agent. What should be the information that they hand off? State and messages. What else? Let's see what people say. Pass relevant information only. The question and the summary of info provided so far. Context, original prompt, and the output of previous agent. Context window, question, answer, and some text, query plus context. Okay, so I think people are saying that there are two things that should be passed between the different agents, right? Generally, these will be abstracted as messages. And the first question we will talk about is what should be in these messages, right? What exactly should be in these messages? And people are saying mostly two things. Either we pass the last agent, if it's basically agent 1 calling agent 2, we only need to worry about the response from the previous agent, right? So basically, I don't care how the previous agent reached this conclusion. I only care about the final output that this agent has reached, right? Another proposal would be, actually, I will need to know what are the final output that the previous agent has produced, but I also want to know what are the thought process of that agent and what are the tools that this agent has called. Does the difference make sense? Basically, between agents, either the agent only pass, in addition to the original question, only passes the output from the caller, or it passes the output and also the thought and the tools that have been called. And all of that will be done through message passing. So basically, the idea is we pass messages between different agents, and we wanted to talk about first, what are the content of these messages? And there are two things. Either you pass the final output of the agent, or you pass the details of how the agent reached to that conclusion or reached that output. So what are the pros and cons of each one? There is like pros and cons. Again, it's almost for almost all design decisions, it's going to be pros and cons. It's not going to be a single solution that works in all cases. There's like very brief situations where like there's a clear answer. There's always pros and cons. So for the first one, what are the advantages of doing this? It's very clear that passing the whole like history or passing all the intermediate steps will increase the memory and will increase the tokens that are used, and it will eat up from the context window. But there are also benefits that we will get. What would be the benefits? So it's basically giving the destination or the final or the next agent more insights about what happened in the past, and it might help actually the next agent make better decisions. It's providing the next agents with more information. So this is going to more likely increase the quality. But basically, complexity will increase. It will eat up from the context limit that we have. Will also increase the cost. And this is again the cost that we have to pay, or the decisions that we have to make. In the whole session, I will keep repeating the word making decisions, because this is what designing, or this is part of designing applications. Not only writing the prompts, but also about how to manage the context between different agents or even within the same agent. So basically, on the flip side, if you only share the final results, you are less likely to run out of context. the cost will be less, and it actually might work better for systems with many agents. So the more agents that you have, the more likely that you will need to only share the final results. Or actually, agents are more complex and they are more likely to have like long intermediate output to be shared. Does that make sense? Does the trade-off make sense for people? How about if the responsibilities of both agents are different? Actually, the responsibilities of both agents should be different. But you can think of examples where you say something like, pull the relevant information about Gen AI and write a report about it. Pulling information from the internet is the responsibility for an agent, for example, that has a specific skill set. And writing a report about it is the responsibility of another agent that requires a different skill set. However, they work together to achieve the same task. So if the tasks are different there, then the two agents do not need to work together. What we're talking about is two agents working together to solve the same question, but they are bringing different things to the table. They have different skill sets. Of course, calling multiple agents will increase cost, will increase latency, and people try to run as many steps as parallel as they can. But sometimes you have like some dependencies between these steps, so you can't actually run everything in parallel. But yes, it will increase cost, it will increase latency. When does the iteration to look for results stop in multiple agents? Is there an accuracy rate for an output? So usually it stops, or basically people usually allocate either a time budget, basically I will allow this to go for X seconds or X minutes or whatever, or number of calls. And after that, they make a decision to abort the call and declare failure, basically. Okay, so this is basically the first point in the communication and state management. Also, one of the things that you should always do is adding which agent is making the call, just to disambiguate. This is agent one, or research agent, or writing agent, or coding agent, so that you actually identify the source of each message. Okay, so going back to the idea of passing messages between agents through the handoff, and basically we talked the first thing about what would be the content of these messages. The second thing that I wanted to briefly talk about it, which is a little bit lower level details about how handoffs actually represented on the implementation wise. I'm not going to show like or run code or anything like that, but I just wanted to give you a little bit of more concrete idea about how the handoff is represented on the implementation side. Usually, the handoff is done through calling a specific handoff tool. So basically, it's represented as one of the tools that an agent can call, and then basically that tool call will be added as an AI message to the history. Right? We know that for any agent or any application that uses an LLM, you have a history of the conversations that happened. We add as an implementation detail, we add an AI message that is basically calling a specific tool. Modeling the handoff as one of the tools is really nice because you can rely on your LLM choosing that I need to hand off this to another agent that is responsible for writing code or drawing graphs or making web search or something like that. You don't have to add a specific mechanism to that if you just model this as a tool. So basically, implementation-wise, online graph, again, it will look like this, where you basically, as we mentioned earlier, this is one of the tools that you will have, which is basically transferring or handing off the control to another agent. So from implementation perspective, you can look at this, or you can think of this as one of the tools, and your LLM will be responsible for choosing that tool. Does that make sense? Let's take another question from the Q&A. Sharing only the final results will only work better for a network of agents, and if there's also an agent who is consolidating the information. Okay, so this is answering question. See if we have other questions here. In network, do agents have to use the same LLM? Really good question. No, they don't have to. And actually, in most cases, it's better to use different LLMs if the responsibilities are completely different. It really varies by application, but no, they don't have to use the same LLM. And that's why we are actually separating them into multiple agents. Really good question. All right. Let's see. Can chaining agents be dynamic based on the context? Yes. And this is basically what I was trying to say around if you add the handoff as a tool, your agent or your LLM will make the call or to make the decision whether it needs to hand off to agent A or agent B. That's basically the idea, that you want to make it dynamic, not very static. LangGraph it strikes a balance between two things. but you want to rely on making that decision so that the quality, or you don't basically don't hard code the decision. Okay. Is it possible to have two agents performing the same task? Agent 1 always gives answer, but expensive. Agent 2 most of the time gives answer, but sometimes no. Agent will call agent 2. Okay, so this idea is very similar to what people refer to as speculative decoding. It's done through, you can do this within the same agent. There's a famous technique called speculative decoding. I would suggest reading about it because it's very similar to the idea that you were mentioning. Right. How does chain of thought processing impact the choices of available agents? Chain of thought is mostly within the agent. It's an implementation detail within the agent. You can expose thoughts to other agents if it helps them, but it will not really be impacting the direct protocol between the different agents. Okay, so let's go to the third question that we had. How do we manage the state for sub-agents? So what I'm trying to get into this point is that we mentioned earlier something like this here, right? Where we said we can either pass the chain of thought or the different tool calls that we made and the different internal reasoning steps that we made, right? Or we can only share the last one. It's very typical to do the share the last one, but what if agent 2 that is making the call and they decided to only share the final output, if the control goes back to that agent, right? So basically what I'm trying to say here is that we have agent 1 that called agent 2, right? And then the control went back to agent 1 again. We're passing only the last message, but agent 1, when the control went back to agent 1, it needed actually the previous processing steps that it didn't pass, it didn't share with all the other agents. So I want to have the flexibility to pass the last piece of information to other agents, but if it ever comes back to me, if the control comes back to me, I want to have the full history. People achieve this by one of two goals. Either you keep everything in the history, but other agents ignore the intermediate information. They see it, but they ignore it. And then basically when it goes back to the first agent, it can actually read that information. Or you can keep that information internally on each. So basically what I'm trying to say here is that you can have a trade-off. You can have like solution in between here, where you make that intermediate information available only to that agent across different calls, but other agents do not have to worry about it so that it doesn't explode the context. Does that make sense to people? Any questions? Let's see. How are the results validated between agents? So the when you say validated, do you mean like some form of quality evaluation or some form of ensuring that there are no errors? Errors are handled by basically having a proper safe error handling, or basically if one of the agents fails, it should fail gracefully, it should send an error message to the other agents, and it depends on the protocol that we implement. If you're concerned about the evaluation, then you should have like some end-to-end evaluation for the system. Why not leverage an summarization to solve context-sized problem? Yes, this actually sometimes happen. This is a really good point. If your context grows, then at some point you may want to stop and summarize that. That's also another option that I didn't include in the slides. Let's see. So there's one master log they all update. Yes, you can think of it as a main log that they all update, but they pull the relevant information that they're only interested in. I won't say like it's a central one. It just keeps propagating and being passed between different agents. Let's see. If intermediate use the history information, will it not impact on their functioning? Sorry, Muhammad, I'm not following your question. If you can post a follow-up, that would be easier. Is this handoff called agent to agent or agent to agent is different? Agent to agent is one of the protocols that implements the communication between one of the protocols that specifies how this handoff should happen. Let's see. Is there a reason why MCP isn't discussed when it comes to standardizing the communication protocol between agents? MCP is designed specifically for LLM or backends or agents calling tools. It's designed for a different use case. There are different protocols like agent to agent and others have mentioned, and it's basically designed for agent to agent communication, which is different than calling tools. Okay, so basically, of course, there are tons of details around how these protocols are implemented. I don't think we can cover this within an hour. So tons of questions, I acknowledge that, but due to time, we can't dive in all the details. The other thing that I wanted to talk about is how adding multiple agents can increase the safety risk. So what safety risks are introduced by having multiple agents? What do people think? What are the safety risks that can happen if we have multiple agents? What do you folks think? For multi-agent system, what are specific safety issues that can happen? Leakage, yes. In any architecture of multi-agent system, actually doesn't matter. Managing governance, yes. Security of, yes. Leakage of personal information, yes. This is a great point. That is, people refer to it as prompt injection. You can read a little bit about that. Authentication, yes. Misuse between different agents. So basically, you can think of a scenario where you have multiple agents, right? Some of these agents are allowed to read information. Like, for example, I have an agent that I authenticated it to read my emails, but I haven't authenticated another agent to use these emails to update a database. What if the reading agent communicates with the writing agent and my information has been leaked? You can read actually about an attack that happened for an MCP server, official MCP server for GitHub, where basically private repo information has been leaked into a public repo information. So basically, the setup of the attack, where basically you have a private repo and you have a public repo. So this, everyone can see it. This, only you can see it, right? And then you have an MCP server that is connected to them. The MCP is allowed to read that information, but it was not supposed to write here. So it's allowed to read. It's allowed to write to the public repo, but not information from a private repo. So basically, this is one of the scenarios where adding multiple or many moving parts can actually result in flow of information that was not intended. So basically, this is related to the permissions and making sure that the flow of the information is intended. There's no bypassing of authentication, or there's no bypassing of different rules that you have. So basically, you can solve this with many ways. Again, from like designing your agent communication should enforce many things. Should actually enforce some kind of policies, right? You should allow, like, basically say, do not tag the information that are read from private sources or authenticated sources with the right annotation, so that the policy is enforced on them. And again, when you think about this, this should be on the platform that supports the agent-to-agent communication. It shouldn't be each agent arbitrarily enforcing these rules. It should be on the platform itself. And this is, again, goes back to why having a platform that supports proper agent-to-agent communication is important. Another thing that you can have is define explicit rules or explicit constraints on things that shouldn't be done. For example, any sensitive information shouldn't be sent to write operations before user authentication. You can enforce having human in the loop before any write or something like that. You can also, from the safety side, you can have like some content filters. Since these are LLMs, they can produce content. In the odd chance the content can be unsafe, could be like abusive content or something like that. So you can actually add some filters that block these content. Mistakes happen. Sometimes people mess up, and then you should have some automatic escalation where humans can always step in and stop these agents. There are many details, but basically the idea, I'm hoping that it gives you like an idea why having a rigorous and solid platform that implements this agent-to-agent communication is important, because it enforces many things, and the application or the people who write the agent or the application developer in this case do not have to worry about these horizontal compliances or horizontal enforcement. Does that make sense to people? Oh. And since some of the folks actually mentioned here, one of the good points that Ahmed mentioned, how can we perform auditing? Which is a really good question. Actually, the reality of working on agent systems is usually answering these questions, which is basically, does the agent have access to this information? Should the agent actually have access to that information? What about other agents that the first agent communicates with it and they try, or by mistake, we actually leak some of the information? How do we even know that these things happened? One of the things that you should be having is proper auditing. Every single time you access sensitive information, you should leave traces that are read from that source for that purpose. And this is the operation ID. So you should be logging everything. And when I say everything, I don't mean the data, but at least logging the access that you have read, logging which resources you have read. You definitely should have monitoring with proper alerting. If something goes wrong, you should have proper alerting that basically triggers the on-call and they can investigate. You should always have like big red button that allows you to have emergency stops because, again, believe me, things sometimes go completely in unwanted directions. Let's see if we have other questions. What team handles the guardrails and policies? Really good question. So bigger companies usually have teams dedicated for safety evaluation, guardrail, and policies that they work horizontally across different product teams. They also work very closely with the platform teams to enforce as much as possible of these guardrails on the platform. So basically towards the beginning of 2023, things were being done completely ad hoc. Every product team who wanted to implement Gen AI features, they will go ahead and implement their own infrastructure. Over time, especially bigger companies realize that many teams are repeating the work. They're trying to implement their agent-to-agent communication protocol. And at the same time, they're trying to implement their safety or guardrails. So they decided to have like a common infrastructure that offer all these capabilities, and you can think of the product team as application developers at this point, that they do not have to think about how to implement these basic capabilities. Instead, they will just think about how to use them. So there has been a push for a little over a year now to push down all of these common problems to shared layer, whether it's an infrastructure or libraries or whatever, so that not every single product team has to implement this. But this is a really good question. Should a proxy enforce policies so all inter-agent communications pass through it? Some people believe that this is a great solution, but I have some thoughts on this. If you enforce something on every agent-to-agent communication, first, you don't know what are the different needs for different agents. Second, it will slow down all the communications between different agents. So you only enforce things that violate specific rules. For example, explicit content or fraud or violent content. But if there's something that is application specific, you should allow applications to configure it. So if it's something that violates an explicit and clear signal, a clear policy, then yes, you should enforce it on the platform. If it's something that is application specific, then you should basically let the applications control it. Okay, I can talk all day long about guardrails and safety and security, but unfortunately, we don't have time to do all of that. So I will punt the discussion for now, but I will be happy to talk towards the end about all things related to safety and security and guardrails. Okay. So since we talked about like measuring how many times things went wrong and being able to alert based on that, there's always a say that says like you can't improve what you can't measure. So basically, as I mentioned earlier, we should have some observability so that we can make evaluation. And you should basically leave traces of different things that happen. What are the traces that we should be leaving in terms of logging? What are the traces or logging that we should be leaving, or the logging that we should be implementing for multi-agent system? What exactly should we be logging? Start time and start and end of a handoff agent, messages being sent. What else? Agent info times and messages. So basically, yes, if any handoffs happen, you should always have like an ID for a trace. You should have specify all the different types of logging, and you should have like a causality tree, which agent called which other agents. You should also logging things that are application specific, like how many tasks did I make or how many steps did I take to solve this question or to achieve or finish that task, success rate, latency, how many times I actually kept running in a loop and then I had to abort. This is actually kind of failures. All of these like operational stuff will help you at least understand if your system has a problem or not. And you can always keep adding fine-grained logging. Again, there are like lots of things around logging and performance evaluation. We'll not dig deeper into this, but I'm giving you some pointers and some hints about like what you can read a little bit more about. In terms of evaluation, as some folks asked actually earlier about like how can we evaluate this, right? You can have like some scenario tests. You can have like some golden outputs. I expect the final output to look like this, and I'll run these questions or these queries through the system, and then we'll compare the final outputs to the golden outputs so that you can basically get an idea about the quality of the system as an end-to-end. In terms of the safety and guardrails, you can have actually adversarial tests where you intentionally try to get your systems to do things that it shouldn't be doing. Things like trying to leak users' data, or try to get the model to talk about topics that it shouldn't be talking about, like violent content or hateful speech or something like that. And if your model falls for it, then this means that you are now ready to launch the application. If your model declines or pushes back on this, then you're ready to release your application. So adversarial testing or safety testing is something that you have to do. And you basically have to have your scenario tests to have like as higher coverage as you can about your application. You can also have like some infrastructure, CI/CD, like for continuous testing. Okay, so that's for the evaluation. Circling back about the idea about the scaling, since we started talking about like when we started at the beginning, some folks mentioned like running agents in parallel and reducing the costs. We all know that running multi-agent system will increase the number of LLM calls, which almost always translates to increase in TPU cost and latency. There are different techniques that people do to allow for higher scaling and increase reliability for your system. One of them, the obvious one, is parallel execution, but it comes at the cost of like paying more money. And we are aware of that. We should be accounting for that. One of the things that we already touched on is if one agent fails, it shouldn't fail your whole system, right? You should be like what people call like crash resilient, or having like a graceful failures, where one agent failing shouldn't take the whole system down, which means you basically need to have like process isolation. You should have proper system design or runs each agent in as much as possible, isolated processes, so that one of them failing doesn't take the whole thing down with it. You should definitely have load shedding as much as you can. You should have like replicate your backend so that if one node fails, not everything fails. If actually failures happen, you should, as much as you can, checkpoint your processing, right? So basically, if your task required calling 7 agents, and after the third agent there's a failure that happened, if you resolve that failure, you shouldn't start all the way from the beginning. You should checkpoint that periodically after maybe each agent. You should checkpoint the outputs and then pick up that computation from there. So you should have like basically some resilience, and that resilience reduces your cost, because you do not have to start from the beginning, which means you don't have to repeat the work, which means you will pay less money. One of the things actually that helps with paying this money, which is one of the that someone mentioned earlier, which basically you can mix different models. So you can actually use cheaper and smaller models for less critical tasks, and save some money or save some of your capacity to use bigger models for more critical tasks. So you can actually mix and match different models with different capacity, with different cost, or with different sizes, so that you can reduce your cost. You should do some form of caching. Like if you have seen this question or a very similar question to it, you should actually bypass running the again, and you should just basically cache your requests. One of the things that actually happen, but this happens on a lower level, which is batching requests to the LLM. This improves the utilization of the hardware. I wouldn't say it reduces the cost or directly reducing the cost, but it increases the utilization of your hardware. One of the very important things, and people overlook it, is budget enforcement. So basically, if you're releasing an application for many, many users, and you don't want some users to either intentionally or unintentionally abuse the resources. Some people may ask questions that require multiple reasoning steps, and they will end up straining the resources that you have on your system. You should actually enforce some budget, as we mentioned earlier, either latency budget or number of LLM calls budget on each question, so that you do not strain your system. So these are a few things or few pointers around how we can basically scale or add resilience to our application. Let's see if people have questions. Is there a concept of business B2B in the context of A2A, basically engaging A2A interaction between enterprises? As far as agent to agent is concerned, it doesn't matter if the agent lives on the same business or not, but there's a notion of authentication. Is this agent allowed to call with that agent or not? Or should we have an additional authentication if we call another agent or not? Not sure if this is what you're asking about or not. When do you stop continuous integration in order to standardize for scaling. I'm not sure how stopping the continuous integration will standardize the scaling. Sorry, if you can clarify this, maybe I misunderstood your question. Does agent have any coordinator, especially if they are sharing common resources? That depends on the architecture that we talked about earlier, right? If you have like a supervisor architecture, then yes, they all go to the same supervisor. If not, then everyone can talk to everyone. What are the top commercially available tools for agent monitoring and observability? Langsmith is the easiest one. I think some folks mentioned using Datadog. I haven't used it, but it seems to be popular and it seems to be integrated with agents as well. These are the two that I have heard about. Let's see. Okay, I don't see other question. If we cache information, how the cache refresh when the LLM update? This is basically depends on the eviction policy, right? You can configure your cache to evict all the information stored if depending on different conditions. One of them could be the LLM. All right, so let's talk about some of the frameworks and then we can see a coding example and then depending on the time, we can talk about other topics or not. So let's talk about different different frameworks that you can use to build multi-agent systems. What are the frameworks that people are familiar with? Are folks familiar with specific frameworks that you can use for building agents? LangGraph, yes, Strand, I haven't used it, but I have heard about it. Init, Google ADK, yes, what else? What is the difference between init, for example, on one hand, and LangGraph and Google ADK and LangChain on the other hand? There's like a clear difference between things like init on one hand and LangChain on the other hand. Yes, init is no code. You can have like no code frameworks. Things like there are many applications, not only init, Zapier, init, and MAANG, which is more suitable for people who are not interested in writing code or not technical by their day-to-day job is not basically writing code. And this gives you less control over what can be done or how it can be done. On the other hand, things like it's mostly UI driven where you connect or define through UI what are the things that you want it to be done. On the other hand, you have things like code-based frameworks like LangChain, LangGraph, CrewAI. One example is LangGraph. I'm not going to talk about LangGraph in detail because we have a coding demo in CrewAI that I wanted to show you. But basically, LangGraph is nice because it gives you some control about the state machine or the state graph that you want your agent to go through. So you define main steps and you let the LLM execute each of these steps, but you force your agent to go through specific steps. One example is it has to be authentication first, and then there has to be Google search next, and then it has to be database read or something like that. So you have some control over how the application will be performed. The other example is CrewAI, which we're going to use for today. Basically, CrewAI is a framework that allows you to define multiple agents in more of orchestrator. You can actually use different architectures, but basically what you have to do is defining multiple agents. You define how these agents will talk to each other. We'll see a coding example, and then they work together to achieve a common goal. So you basically define agents. Each agent will be like specialized in a specific task or a specific goal or a specific domain. And then you create a task. You say like, I want this question to be solved. And then basically you configure your agents and they will work together to achieve a final goal. We'll see an example. The example that we'll see is basically creating an agent that researches specific topic that you ask it, and then it will write some information about that topic, and then it will publish this on social networks. So let me show you if we have slides about this. Let's see. It's over here. Yeah. So basically, our demo will basically take a user input. There will be an orchestration layer. And then this orchestration layer will call multiple agents and they will give us a final output. The specific example that we will have is basically we'll have like a question and we'll have multiple agents that will help us achieve that goal. The first agent, we call it research agent or researcher agent, which will learn about that topic. We'll use an example, about a question about economics. Our LLM may or may not know about this question. It can use its internal information or internal knowledge to get information about this, or use Google search tool to get more information. Once it has that information, it will pass the flow to another agent that will basically write a more comprehensive answer to that question. So basically we call it the writer agent. The third agent is an agent that's basically writing about this topic for social media posts. So basically each one of these agents will be specialized in one specific task, and they will work together to basically achieve that final goal. So the first agent is the researcher agent, which will basically pull some information to better understand this domain. And then the second one is writing or analyzing the information. And the third one is publishing to social network about that specific topic. Does the problem setup make sense to folks? Let's see. So there are many questions, so it's hard for me to go through all of these. Let's scroll all the way to the bottom. Give me a moment. I'm not sure what is happening. Okay, let me scroll all the way down.
I think people have used both chat and Q&A to interact with you, so that's become like super cluttered.
Yeah, and for some reason it keeps scrolling.
By the way, I'll share this Crew AI demo link with folks. I hope it's okay. The same one that's on the deck, right?
I will. Is it okay if I share this in the chat? Because I made a few changes, so I think it's
okay.
Good if I update that. Okay, I'll send to folks the latest one. So let me switch. Yeah. Okay. Let me switch tabs, and then this is basically the demo that will do exactly what we mentioned. Are folks familiar with Google Colab? If you're not familiar with it, it's the easiest way for running Python code. You run it technically in the browser. You don't have to install anything. The code will be structured in cells, and you can run each cell in isolation, or not really in isolation, but you can run each cell alone, and you can inspect the output. So it's a really easy way to have some Python proof of concepts, and you will have to install all the dependencies explicitly within your notebook. Once you close the notebook, the runtime gets disconnected, and you will have to run the installation again, similar to what I am doing here, even though I ran this before the session. So this is basically, it's very similar to Jupyter Notebook. Yes, they are very similar to each other. So it will take a moment to download the install the dependencies. Let me take questions in the meanwhile. One question on the Q&A that says, is there any auto discoverability mechanism for agents? Yeah, this is a really good question. How can we actually allow agents to know about each other? Do we have to explicitly let them know? I think this will be done on the platform level. One of the ways that I have seen people doing it is basically you have a registry, like a single registry, and every time you create an agent, you say like register agent. And then there's a central place that each agent goes to pull the information of the recent agent that exists. That way, you don't have to discover other agents yourself. It's packaged and supported by the platform, which goes back again to the importance of having a single platform. Okay, awesome. So the installation is done. This cell is basically importing all the necessary libraries. It's just like all the libraries are similar to Python import code blocks. You just basically import everything that you need. This cell is basically allowing me to enter my OpenAI API key, because we're going to use LLMs from OpenAI. This is just a way for me to copy paste my API key without it being visible to everyone. And I will store and save that in a variable called OpenAI API key. I will create LLM object. Here you can see that I'm creating this using chat OpenAI, which I am importing from LangChain. So this is basically relying on LangChain to use my API key to connect to OpenAI. Now I have an LLM object, right, that I can use to connect or to OpenAI and then send requests to them. As we mentioned earlier, that we are going to have multiple, there are multiple things. Okay. So there are, as we mentioned earlier, we're going to have 3 agents. One of them is doing research. One of them is connecting to writing the summary and the analysis. And the third one is connecting to social network and posting content. So basically, we will have different functions that basically one function that creates the post for me, just the text post for me that will be posted in the social network. You can see that we're writing some simple prompt that says, write a post on this specific platform. It could be LinkedIn or Twitter, and talk about this specific topic. So it's just a function that accepts some parameters and populate this prompt and eventually calls the LLM. And the other function is basically making a request to the post request, basically to post a specific content to different platforms. So it's just a simple Python implementation that connects to different social networks and create a post. What really matters is how we're going to package this as a tool. This is just a Python function. What really matters is how we can package everything as a tool. You can see here that within the make social copy tool, the tool that will be used by an agent to call or to create a post, you can see here that we're creating a name and a description for the tool, because these will be used by the to know whether it needs to call this tool or not. So this is really important to write this in a descriptive language, because your LLM will use this. What's going on? Because your LLM will use this to decide whether it needs to use this tool or not. So we are packaging this as a tool. You can see that there's something called base tool, and the base tool is imported from Crew AI. So it allows me to create tools as Python function. I need to create the name and the description. And what happens, it's not technically not a Python function, it's a Python class. And I have to define a run function. The same for the tool that posts the content on the social network. I have to create it as a class, create the name and the description, because this will be used to select the tool, and eventually I define the run function. So basically, I create an instance of that class, the make social copy and the post available hook. The name is important here and the description is important, and basically here you have your custom Python implementation. So this is basically the first thing that we'll create. The two tools, for one of them is for creating posts on social network, and the other one is to actually publish this post. So let me now define my agents. Now I'm ready. I have all the building blocks I have to define. Then my next step is defining my agents. So here I will import agent from Crew AI. This is all what I have to do. Here again, I am defining the rule and the goal of each agent. Similar to tools, the name and the goal of the agent will be used by other agents, whether other agents directly or through the orchestrator or the supervisor, to select which agent will be used. The rule and then the goal as text or strings are extremely important. And then basically we define the LLM that this agent will use. Here we didn't define any tools for the researcher agent. This means that it will use its internal information to do the research. Will not, for example, use Google search tool. If we needed it to do that, then we should have created a Google search tool and added it to it. Similarly, the writer tool, it writes and drafts posts with a specific architecture or a clear structure, but it's not using any tools. The only agent that uses tools is the social agent. The social agent, again, we give it a rule and goal and backstory, just describing what it does. And you can see clearly here that we are giving it tools. So basically, these are three agents. One that researches the problem. It's more of like using its self-information. It's not using any tools. The other one is the writer, which writes a description about the problem itself. And finally, the social one that actually uses tools. Now, to connect them, we'll see how we can connect them. But basically, before we connect them, we can actually create different tasks. So we can create a task that says, research the topic, state of Canada's economic growth in 2020, blah, blah, blah. You just basically ask it to research a specific topic. And then you create another task where you basically explicitly tell it, write a structured content about this topic. And the final one, create a social media posts. So you create an agent, and then for each agent, you create a corresponding task. And then you assemble everything together in a crew. So you have a crew, which is defined by your agents and tasks. Each task maps to an agent. And then you can basically start your crew by saying crew.kickoff. And then basically you ask questions to that crew. So let me run this. So here we defined the task because a crew consists of agents and tasks. First thing is we define the agent and then we define the tasks. And the last thing is we are assembling the crew. We are basically telling it what are the agents and what are the tasks. And then basically it takes questions, and you can see that it will rely on the first question that is basically asking it to research the state of Canada's economic situation or growth or whatever. And let's actually go through the logs together because the logs are actually very interesting. You can see that we enable the verbose answer, so we can see everything that happens. The first thing is basically saying that I will start with the researcher agent, and the task is research the topic state of Canada's economic growth and blah, blah, blah. So it have like a task ID. Let's actually say yes here. Let's go through the logs from the beginning one more time. So the first thing is the researcher agent, right? We can see the name of the agent, the ID, which is 1A17. And then basically we can see there's like some information about Canada's economic situation or economic growth. And then you can see that task 1A17, blah, 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 is completed. And then it handed off the flow or the control to the writer agent. And you can see the task is saying write a structure 250 to 300 word. So this is basically the name of the task that we created here. So it knows what it should be doing. And the control has been handed off to it from the researcher agent because the researcher agent made the decision that the right next thing is the writer agent, which basically, again, we have the trace of the first task that has been completed, and this is the next task that is in progress. And similarly, it improved the writing based on the information from the research step. And then this is also completed and it was handed off to the social media strategist, which also knows the task from the description that we gave it here. It identified the task, and then the final thing that you can see actually that this agent has a thought that I need to create. Does anyone know actually why this agent has a thought in the tool output, but the other ones do not? One question saying how data is passed from one agent to the other. Yes, this is handled by Crew platform. Yes. So the only reason that this agent had thoughts and used tools is that if you go back to the description or definition of these agents, this is the only agent that has tools. Other agents did not have tools, so they didn't need to think about which tools to use in the first place. So this agent doesn't have tools, that agent doesn't have tools, that is the only agent that has tools. So basically that's why it has some thoughts and different tools to use. So it used the make social copy tool. You can see that the inputs for the tools and the output from the tool is the actual post. And since we are actually running this in just debug mode, we didn't actually post anything. So it only just wrote the name of the tool. So it did this for LinkedIn, it did this for Twitter, but it didn't actually call any webhook because we're just doing this in just debug mode or dummy mode without actually posting anything on LinkedIn or Twitter. Finally, you can always export or log the traces. You can see the traces in a more summarized format. And then finally, it just tells you that the workflow is completed. So this is really a simple notebook or a simple example that shows an end-to-end workflow that works in connecting three agents together to achieve a simple task. Any questions about this? Let me go to the Q&A, see if we have questions. There are many questions I know, but let me try to answer some of them. In LinkedIn, does a post write in your account? Here, I didn't write in my account because let me actually show you what happened. Let's see. In some of the descriptions, I said you shouldn't actually try to go and post on LinkedIn. You should just make it as dummy post. Here, let me show you. Here, publishing automatically, just showing what the post would look like. Because in some of the instructions, I told it if the URL is not specified to an account, you shouldn't post on LinkedIn. For testing purposes, do not publish automatically, just show what the post will look like. So in the task, I explicitly told the LLM to not try to post it, just showing the content will be enough. Let's take more questions. If the code asks to publish the post, but if your instruction in the text say do not post it, it automatically understand not to post it. Yes, it follows the direct instructions. LLMs are getting even better at instruction following. Who this tool where you are writing and running this program? What is this tool? So the tool is a Python function. You define the tool and you define what the tool can do here. This is what the tool can do, and this is the callback that will be executed once this tool is called. How about, let's see, sorry. Why is giving, I don't know why this keeps scrolling. Why is this giving an agent a background important? This is just part of how the agent being defined in Crew AI is done. You just give it basically the skills or the capabilities of each agent. Let's see. I don't know why the Q&A keeps scrolling without me touching anything. how to create front end to visibly see in the form of UI possibly interactive. It's similar to building any front end, right? Like you just have to add the right endpoints in your back end that exposes the information that you want. And to expose the information from QAI or LangChain, you need to know which APIs to call so that you can propagate that to the front end. Let's see. What should be the value of role for each agent? This is basically depending on what the agent is doing. Like this is a researcher agent. This is like custom string that you write, similar to the name of the agent. So it should be descriptive of what agents are capable of doing. Let's see. Okay, let me actually wrap up the discussion and then we can go to the Q&A because for some reason it keeps us scrolling and there's like around 170 questions. So we'll keep scrolling back and forth. So let me quickly wrap up the remaining slides and then we can have like maybe 10 minutes or so.
Ahmed, let me do one thing. Sorry to interrupt. What I'll do is I'll try to clean up the Q&A section. If you're going to take 5 minutes, I'll clean it up.
Yeah. Yeah, that would be really helpful because for some reason it keeps scrolling without me doing anything. Okay, so hopefully this demo clarified a few things on or made things a little bit more concrete. I had literally a couple of slides on the things that I have seen as to watch out for before you actually launch your application or before you publish or release your end-to-end agent. One of them is oscillation loops, where basically your agents keep running in infinite loops. This can happen for many reasons. Either you have agents are trying to do the same things or low quality LLM. And basically the other thing that you should have an explicit stop criteria or kill switch, you allocate a latency budget or you allocate number of calls that you say after that, we're going to stop the execution. And also plan drift, where some people have observed that LLMs are more likely to overcomplicate the problems. Watch out for these. Make sure that your evaluation covers cases like this. Final checklist is have clear roles and separation of responsibility between different agents. Optimize your context very carefully because different agents can eat up from the same context, and you should have proper design and proper limit for that. Focus on safety guardrails. It's extremely important. It distinguishes between a proof of concept and the final application. Allocate budget for each request. Otherwise, people will abuse your application. We talked about the stopping condition. We talked about the structured communication. So invest in a good infrastructure to abstract many of the details for you. Monitoring and evaluation is extremely important. You cannot improve what you can't measure. You need proper monitoring and you need some evaluation offline and online. And always think about scaling, right? The more users you get, the more traffic you get, you have to have more of an incremental scaling.